there, kiddos. Welcome back to second semester. Here's our first video. We've taken it easy for the last week working on our line projects, which I hope you're still continuing to focus on. Remember, they're due this Friday, the 18th. So today we're going to talk about scatterplots and correlation, which is not new information to you. You talked about scatterplots when you were in 7th grade. You saw them again when you were in 8th grade. So this is really just going to be a review. First, you have a definition of what a scatterplot is. A scatterplot is a graph with points plotted to show a possible relationship between two sets of data. It is an effective way to display different types of data. It's all it is. Whenever you have two types of data, you use this a lot in science when you are doing experiments and you want to plot a graph of what's happening. A scatterplot's always an effective way to do that. So it just shows the relationship or a possible relationship between two different things. All scatterplots have what we call a correlation, which is just fancy math word for relationship. Every scatterplot shows some kind of a relationship. There are 3 different types of correlations. There is a positive correlation, like this one, this first one. A positive correlation, the points in general increase as you go from left to right. And so if you were to draw a line through these points, it would increase from left to right and would have a positive slope. So we say it has a positive correlation. The reason it is a positive correlation is because both sets of data increase. Whatever it is that you are graphing on here, no matter what it is, as the x values increase, the y values also increase. And since both things are increasing, or since both things are doing the same thing, then you have a positive correlation. Negative correlation is, if you look at it, the points in general decrease from left to right. So if you were to draw a line, it would have a negative slope, and so it has a negative correlation. We say that it has a negative correlation because, and I'm going to do my best to draw this without it looking special, as the y values decrease, the x values increase, and so it makes this pretty little n, okay? And your line decreases, and so it has a negative correlation. As one thing decreases, the other thing increases. When that happens and your two sets of data are doing opposite things, you get a negative correlation. If something has no correlation, these are the easiest to spot because you just have dots scattered all over creation. Some of them decrease, some of them increase, some of them are in the same spot. They're just sort of everywhere, and you can't really see a relationship. That's because there isn't one. Whatever the two sets of data are that are being graphed here have nothing to do with each other. And so we say there is no correlation, and so there's no relationship between the two things. So that is correlation. I'll scroll back up so you can get back to the definition should you need it. But that is what a correlation is. Now we're going to spend the rest of our time looking at graphs, determining the type of correlation, and then we're going to talk about line of best fit in just a second. So first one, we're going to describe the correlation that's illustrated in this scatter plot. So first of all, we have a scatter plot about visitors to the beach. And you can see my two pieces of data are average daily temperature and the number of visitors. If you look at the graph, first of all, there's a break in the graph here. That's not going to be very important for what we're doing because we're not going to be predicting anything. We're just looking at what's happening. As the average daily temperature increases, as we go this way on the x-axis, as these numbers increase, the number of visitors to the beach also increases because down here there aren't very many visitors, but when I get over here to where it's 96 degrees, there's a lot more. So both things are increasing, so this has a positive correlation. And here's how we would say it. As the temperature increases, visitors increases. And so you can see both things are increasing. That's why it has a positive correlation. So now let's take away the graph and let's just talk about, because the graphs are easy. You can look at it and you see, is it positive, negative, none? Sometimes you don't have a graph. You're just given a situation like this one. The average temperature in a city and the number of speeding tickets given in the city. And you have to decide what kind of correlation it has. Well, first of all, let's talk about our two sets of data. Our two sets of data are the average temperature and the number of speeding tickets. If you think about this, and I know that you can argue this, and please keep in mind that temperature and weather do not equal, okay? Just because it is 20 degrees outside does not mean that it is snowy and icy. It should just mean it's cold outside. I mean, for example, Right now, outside, Sunday afternoon, it's not very warm, but there is not snow or ice. It just happens to be cold. So cold does not equal snow and ice. So you can't say that, yes, when it's cold, you drive slower because it's icy. Not always. Temperature and weather are not the same thing. But if you think about it, okay, right now, I guarantee you there are just as many people out speeding as there would be if it were warmer outside. The number of speeding tickets a police officer writes has nothing to do with the temperature outside. What it has to do with is the number of people that break the speed limit. That's the only thing it has to do with. So this has no correlation because the number of speeding tickets has nothing to do with the average temperature. The two things are not related. So this has no correlation there. The two things are not related. Let's try another one. A runner's time and the distance to the finish line. If you think about a race, any race you run, okay, short race, long race, cross-country race, a sprint, it doesn't matter. The time a runner runs and their distance to the finish line. The longer you run, the closer you should get to the finish line. If you are running a race where the longer you run, the further away from the finish line you are, you're going backwards. And that's not how races are supposed to work. You are supposed to get closer to the finish line. So the longer you run, the closer you get to the finish line. That means that this is going to have a negative correlation. Here is why. This has a negative correlation because as your time increases, the longer you run, distance decreases as you start getting closer to the finish line. So one thing increases, one thing goes up, and the other thing goes down. And so you have the opposite thing happening, which makes it a negative correlation. So 8 and 9 are the same. You want to identify the type of correlation and explain why. The explain why is where you have to write the sentence. As this happened, then this happened. So the number of members in a family and the size of the family's grocery bill. Think about this one logically. What happens to your grocery bill as the number of people in your house increases? The more people there are, the more money that has to be spent. So this has a positive correlation because as members increase, then bill also increases. So they are both increasing, and so you have a positive correlation because this goes up and this goes up. Now, the number of times you sharpen your pencil and the length of your pencil. What happens to your pencil when you sharpen it? It gets shorter. The more you sharpen the pencil, the shorter it gets. So, here's what happens. So times sharpened, the number of times you sharpen your pencil, as it increases, the length of your pencil decreases because your pencil gets shorter as you sharpen it. That's how it works. If you don't have a pencil that gets shorter when you sharpen it, it is either mechanical or a special pencil. So this has a negative correlation because as one thing goes up, the other thing goes down. They are doing opposite things. So let's talk about line of best fit. This is the important part. Line of best fit you will use in this class. You will also use when you get to science. Line of best fit or a trend line, they are the same thing, is a line that comes closest to all of the points in a data set, and this line describes the trend. We use the line of best fit to make predictions. The line of best fit can be used to make predictions based on the data. And that's what we're going to do with it. That's the point of a line of best fit. We'll draw it in, we'll look at it, and we will use it to make a prediction about what's going to happen, because this is what has happened. Now what do you think is going to happen? So a line of best fit, it is not an exact science, okay, because not everybody's line of best fit will be identical, but a line of best fit is a line that comes closest to all of the points in the data. Usually it runs through the center of the data. Half of the points fall above the line and half of the points fall below, but that's not always the case, as you'll see in this example. So you have a scatter plot that shows the relationship between the total amount of money collected at the concession stand and the total number of tickets sold at a movie theater. Based on this relationship, predict how much money will be collected at the concession stand when 150 tickets have been sold. So we have this scatter plot, and the trend line has been drawn in. This line right here is the line of best fit, and you will see not every point is on the line because it's a scatter plot. It doesn't make a straight line, but it's very close to all of them. These 2 points or these 3 points are on the line, and then these 2 points are very, very close to it. So that's why it is the line of best fit, because it's the line that best fits. We want to know how much money will be made when 150 tickets have been sold. Well, 150 tickets would be, I apologize, about right here. If you look, this would be 20, this would be 40, this would be 60, 80, 100, 120, 140, which means this would be 160 right here, because this goes up. I apologize, this would be 180. I was right the first time. It's 160. Every little line counts for 20, which means 150 is about in the middle right here. And so if I draw an arrow up to my line right here, this is where 150 is. I want to see where it matches on my y-axis over here, and you see it would be somewhere between 7 and 800, which makes it about $750. That's what we use the line of best fit for. So now let's do one where we have to draw in the line of best fit and then make a prediction. So here we have a graph that shows how many number of wrapping paper rolls rolled. This is a fundraiser. Some kids, choir, band, orchestra, somebody are selling wrapping paper to raise money. And so here we have the number of rolls that got sold and how much money got raised. The first thing it asks is for us to draw a trend line. So it wants the line of best fit. And if you see, look, these lines are increasing from left to right, which means my trend line should increase from left to right. These points right here pretty much line up in a straight line. So that's where I'm going to draw my trend line, is through those points, because it will match most of them if I do that. So I'm going to draw a line that cuts through those points, and you see it makes pretty much a straight line. Not perfect. I've got a point down here that's not on the line and a point right here that's not on the line, and this one's not really on the line, but it comes pretty close. So that would be my trend line. Based on that trend line, that line of best fit, I want to know how many wrapping paper rolls I need to sell to raise $500. Well, the money raised is right here. Every line counts for 100, so 1, 2, 3, 4, 5. I'm looking for 500, which goes right here. And I need to know how many wrapping paper rolls that would be. Well, if you look down here on rolls sold, each one of these is 25. So this would be 25, 50, 75. So to make $500, I would need to sell about 75 rolls of wrapping paper. That's scatter plots, that's correlations, that's trend lines. The things that you need to really focus on. I need to learn how to spell, first of all. The things that you really need to focus on are correlations. There are 3 types: positive, negative, and none, and you need to be able to recognize them either from a graph or from a statement. You also need to be able to go from a graph and write me a statement. Tell me what's happening. As the number of rolls increased, the amount of money raised also increased. So you're telling me in a sentence what is happening. You need to be able to draw in a trend line. That will take the most practice because it's something you're not entirely familiar with, and we will practice that more tomorrow when you get to class, and I will see you then.